Hi, this video will derive an individual's demand curve, starting with the budget constraint and showing you at various different prices for that particular good how we come up with an individual's demand curve. We will also show you the price consumption curve, which is a tangency of the optimal bundles at various prices for that good. So here's the scenario. An individual buy only two goods, wine and beer. W represents wine, B represents beer, and the income of the individual is noted as I. So the budget, all your income, is going to be spent on wine and beer. The money you spend on wine is the price of wine times W, the amount of wine that you buy. The money you spend on beer is in a similar fashion. The amount of beer you buy, B, times the price of B. Given that wine's on the vertical axis and beer's on the horizontal axis, we need to solve this budget for W. So to solve this, you need to subtract B times PB, bring that to the left-hand side. So we're here. And then finally, to get W by itself, divide everything by the price of wine. This I over PW gives you the intercept term. This price ratio is the slope, shown on the next graph. So this line in blue is our budget constraint, which comes from this equation that we just drove. Now let's assign some values to our prices and our income. Let income be $4.19, I know it's a funny number, and let price of beer be $12 and the price of wine be $35. Again, wine's on the vertical and beer's on the horizontal. So this is our blue budget constraint, and this pink indifference curve is the indifference curve that lies furthest from the origin, and this point E1, or bundle E1, which is 2.8 units of wine and 26.7 units of beer, is the optimal bundle for this given price of beer of $12. So this tangency is the optimal bundle. Now, this below it is a graph that has beer on the horizontal, again, beer on the horizontal for both graphs, but this has tracks the price of beer, which is $12 in this example. So what we're going to do next is we're going to drop the price of beer. What happens to this budget constraint? It gets flatter. So now we can get a new optimal bundle on a higher indifference curve that is better than I1. So let's show you that next point. So here is our new price of beer, which is 6, dropped from 12. The price of beer has been cut in half to 6. So here's our flatter budget constraint. Here's our new optimal bundle, E2. This is, again, this is a tangency of this indifference curve, the pink indifference curve with the blue budget. And now the price of beer of 6, the consumer wants 44 units of beer. So once again, 44 is on the horizontal of beer, and now the price has been cut in half. So this is a second point on a demand curve that we're deriving. So let's do one more example. Let's drop the price of beer further. So now let's drop the price of beer even less than 6. Let's make it 4. This budget constraint gets flatter once again, and now you can get an even further indifference curve with an optimal bundle of E3. Note at E3 you are consuming more of both wine and beer. But again, tracking the beer consumption on the horizontal, this 59 units of beer translates to a price of $4. So 2 points to make here. These optimal tangency bundles, if you plot these points and then connect a dot connecting those, will provide you with the price consumption curve. Some books call this PCC. Beneath it, showing the optimal bundles, E1, E2, E3, where you have price of beer on the vertical and the quantity of beer on the horizontal, this is deriving an individual's demand for beer. Note the downward slope, hence it obeys the law of demand. At lower beer prices, you consume more beer. But also note one final point. At lower beer prices, you're consuming not only more beer, but you have more money spent on the other good. You're also buying more wine.